Good morning, everybody. Today we're going to start our math lesson by looking at our word problem of the day. But before we do that, let me go ahead and have you guys get your whiteboard, your marker, and eraser. You have a minute to do so. All right. Now that everybody has their marker and eraser and their whiteboard, let's look at today's word problem. The fourth graders are going on a field trip to Raleigh, just like you did last month. There are 87 fourth grade students. 3 students can ride in each car. How many cars will be required for all students to go to Raleigh? I'm going to give you about 4 minutes to solve this problem. Actually, not even 4. I'm going to give you 3 minutes to solve this problem. Go. The fourth graders are going on a field trip to Raleigh. There are 87 fourth grade students. 3 students can ride in each car. How many cars will be required for all students to go to Raleigh? All right. Now, I'm going to give you 30 seconds to talk to the person sitting next to you about how you solved your problem. Go. All right. Now, let's go over this problem together. I'm going to read it again. It says the fourth graders are going on a field trip to Raleigh. There are 87 fourth grade students. Let's stop right there. What have we learned in these two sentences? Well, we learned that they're going to Raleigh. We also learned that there's a total of 87 fourth grade students going. Let's look at the next sentence. 3 students can ride in each car. All right, stop right there. I'm actually visualizing this. I'm seeing a car. Of course, there's the driver, but that's not what I'm counting right now. I see a car with 3 students inside of it. So I know there are 3 students in each car. So question here. What does the car represent? I'm going to give you about 10 seconds to maybe talk to each other. What do the cars represent? Go. The cars are your groups. Okay? So you're going to have groups of 3. Okay? So we know we're going to have groups of 3. Okay? The students are your objects in that group. So you're going to have groups of 3. Then it says, how many cars will be required for all students to go to Raleigh? So that's our big question. I'm going to write that one down here. How many cars will be required for all students to go to Raleigh? Now, the word required here means need. So basically, how many cars will be needed for all students to go to Raleigh? Okay, so that is my big question. Now, I don't need to know any more information. This is a one question problem. So let's go over here to our picture here. And I kind of already drew a picture here. I can visualize my groups. Now the question is though, is how many of these groups of 3 will I need? So blank, I don't know, groups of 3. So that is what we are trying to figure out. How many groups of 3? Each car is a group. Okay. Now, this is being solved by division. So our equation would be to take all those students, all 87 of them, and I'm going to divide it by 3. Remember, the 87 comes from how many students? And the 3 comes from how many in each group? So groups of, okay? Groups of 3. Not 3 groups, groups of 3. So I'm going to do the box method. Put what I'm dividing by on the outside, 3. All right, I'm going to ask myself, how many times can can I take 3 out of 8? Or how many times does 3 go into 8? Well, when I look at the multiples of 3, 3, 6, 9, the closest I can get to that 8 is 6. 9 is too much. That's the second multiple. So I'm going to write 2 up here. 3 times 2 is 6. So I'm going to subtract that out. 8 minus 6 is what? 2. Remember that 2 is going to get dragged all the way up to be in front of that 7. So now I got to ask myself, how many times can 3 go into 27? Well, I'm going to keep going on my multiples list here. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Oh, there's 27 exactly. And that is the 1, 2, 3, 4, 5, 6, 7, 8, 9th multiple. Now, if you know your multiplication, you know that you won't have to do this. You can actually count by multiples of 3 and see how many, or you just might know that 3 times 9 is 27. So I'm going to put that there. Now I'm going to do 3 times 9 is 27, subtract it out. I have no remainders. My answer is up here. So how many cars do they need? They need 29 cars to take all of those fourth graders to Raleigh. Now I'm going to set my alarm. Miss Martinez has already or should be passing out your graph paper math journals. I'm going to give you a minute to grab your pencil. Actually, I'm going to give you a minute and a half to put everything away and grab a pencil. And Miss Martinez, if they need more than a minute and a half, that's fine. Go. "30 more seconds. If you already have your graph paper math journal and your pencil, go ahead and open up to wherever we left off on Friday. We're just going to keep continuing on. All right. Now, like I said, we're just going to continue on from where we left off on Friday. If you have room on that page, just keep going down on that page. If not, go to your next blank page. At the top of that page, or wherever you are at, I want you to write this equation down. 5 divided by 367. Now, remember, you can write your equations this way, or you can write it this way. But for the sake of today's lessons, I want you to write it like this. Now, this is a 3-digit number, 367, being divided by a 1-digit number, 5. So in our box, we're going to draw a box. Remember, this is very similar to the box method for multiplication. We're going to draw a box, and we're going to divide it into 3 boxes. Explain why are we dividing this into 3 boxes, class? Very good, because 367 is a 3-digit number. If this was a 2-digit number, let's say we didn't have that 7 and it was 36 divided by 5, how many boxes would you have there? 2. Very good. So we're going to have 3 because it's a 3-digit number being divided by a 1-digit number. Inside each one of these boxes, we're going to write one of these numbers, either the 3, the 6, and the 7. So 3, since the first digit, will go inside the first box. The 6 will go inside of the second box, and the 7 will go inside the third box. What we're dividing by, 5, will go on the outside. Now, if you know your fives, your multiples of 5, then you don't have to write your multiples of 5. But if you need them, write them, okay? Now, we need to ask ourselves, how many times can 5 go into 3? Well, let's see here. 5, 10, 15. When I look at the first multiple of 5, it's 5. That's already too much. Remember, we're trying to get as close to 3 as we can, and the very first multiple of 5 is 5, and that is way too much. So because the first multiple of 5 is bigger than what we're looking for here, that 3, I'm going to put a 0 up here to show that 0 can't go into 3. Sorry, not 0. 5 can't go into 3 at all. So now I got to do 5 times 0. Well, what's 5 times 0? 0. So I'm going to do 3 minus 0. And what's 3 minus 0? 3. Now, because I have some numbers right here, some leftover pieces, I got to drag that 3 up to the next box, and I want to put it in front of the 6 and make that a 36. Now, you may know that 5 times 7 is 35, and that is as close as you can get to 36 as you can possibly get. But if you don't, you can keep listing. So 5, 10, 15, 20, 25, 30, 35, 40. Oop, 40 is too much. I don't want to go there, so I'm going to back up one. 35 is as close as I can get to 36. And it is the 7th multiple. So I'm going to put that 7 up here. And now I'm going to say 5 times 7 is 35. And I know 6 minus 5 is 1, and 3 minus 3 is 0. So any leftover piece I have there is 1. I'm going to drag that 1 up to the 7 in the next box. And remember, if I have any leftover pieces, I got to drag it up to the next box. And I have 17. Now I'm going to put that 1 in front of that 7 for 17. Now, I'm going to look at my multiples list, or I may know. And I notice that the third multiple of 5 is 15. The fourth is 20. That's too much. So 15 is as close as I can get to 17 without going over. Again, you may know that 5 times 3 is 15, and that's as close as you can get. But if you don't, you can always list your multiples. So since this is the third multiple, I'm going to put the 3 on top of that box. 3 times 5 is 17. Sorry, not 17, it's 15. My goodness, Miss Lawton. 15. Seven minus 5 is 2. 1 minus 1 is 0. Now, we are in our last box here. I can't drag this 2 up to the next box because there isn't anything. So this 2 right here, that is our remainder. These are the leftover pieces after we took that 367 and divided it into 5 groups. We will have 2 pieces left over. Because remember, when you are dividing, you are making equal groups. So when I look at here, my answer is actually up here. 73, remainder 2. Now, so remember how we write that? We would write the 73, and then we put R for remainder 2. So that means that 37 remainder 2 means that we can make, not 37, 73. Miss Lawton is crazy today. We can make 73 equal groups with 2 little pieces left over. That's our remainder. Remember, remainder means leftover pieces. Like if you have leftover food, that is the remaining food from that meal. So they're the leftovers. This is leftovers. Remainders is what we call them. Now, I'm going to give you a couple of seconds to catch up with me. Now, let's look at another one. So I drew a line underneath all of that. If you have enough room, you can draw a line under, or if not, you can go to the next page. Let's look at something like this. 4, sorry, not 4, 64 divided by 4. Now, this is a 2-digit number being divided by a 1-digit number. So my box is going to only have 2 boxes on the inside, like that. Go ahead and let's set this up. If you need to, you can look at the screen to see how to set it up. If not, you can go ahead and set it up. Now, let's ask ourselves, how many times can 4 go into 6? Well, if I use my multiples of 4, 4, 8, 8's too much. Remember, I'm trying to get as close as I can without going over. So I'm going to back up 1. 4 was the first multiple I said. 4, 8. 8's too much. 4. So 4 is the first multiple. So I'm going to put 1 on top of the box that says 6 to show that I can only get one group of 4 from 6. 4 can only go into 6 one time. So then 1 times 4 is 4. I'm going to subtract it out of that 6. So 6 minus 4 is 2. Very good. Since I have some little pieces here left over from that, I'm going to drag that 2 up to the 4. And I'm going to put it in front of the 4. So now it is a 24. Now, I can use my multiples of 4 to figure that out. 4, 8, 12, 16, 20, 24. Oh, 24 exactly. And that's the 6th multiple. So 4, 8, 12, 16, 20, 24. 1, 2, 3, 4, 5, 6. 4 times 6 is 24, and that's what we're looking for, as close as we can without going over. So I'm going to put a 6 up here to show that 24 is the 6th multiple of 4. I'm sorry, of 4. No, but 24 is the 6th multiple of 4. There you go. And then I'm going to say 6 times 4 is 24. I'm going to subtract those two. 24 minus 24 is 0. So this one has no remainders. That last box is a 0, so it has no remainders. So our answer is just up here, 16. So 64 divided by 4 equals 16. When we looked at our problem up here, we had some leftover pieces in our last box. That became our remainder. That's why I had to put R2 after that 73. But in our problem here, there was no remainders in that one, so we'd say 16. Now, if you wanted to get really picky, you could say R0. You don't have to. If there are no remainders, you do not have to put that there at all. All right? So let's look at another one. And I'm going to give you some time to solve this one on your own. (673) divided by 2. Go ahead and try solving that on your own. I'm going to set my alarm for about 3 minutes, and then I want you guys to solve it on your own, and then we'll look at it together. All right, you may begin. All right, let's look at what we have done so far. I'm dividing my box into 3 boxes because this is a 3-digit number being divided by a 1-digit number. That's 673. Each digit will be in its own box. And that 2 is written on the outside because that's what we're dividing by. Now, I bet you can tell me how many times 2 can go into 6. 2, 4, 6. It can go in exactly 3 times. So I'm going to put a 3 up here. What's 2 times 3? 6. Very good. So I'm going to put 6 inside of the box underneath the 6 on top. Subtract it out. 0. Now, I have nothing here. Now, 0 is an amount, but it's not something I can drag up here. Okay? So Even if I did, let's say I did drag that 0 up, that won't change the value of that 7 at all. So now my next question is, how many times can 2 go into 7 without going over? Well, 2, 4, 6, 8. 8's too much. Let's back it up. 2, 4, 6. It can go in it 3 times. So I'm going to write a 3 up here. Now, what is 3 times 2? 6. Very good. So I'm going to put a 6 here underneath the 7. Remember, make sure you are lining up your place values. Don't put the 6 underneath that 0 because that 6 is not in the tens place. It's in the ones place. It's not 60. It's 6. So 7 minus 6 is 1. Now, since I do have something there to pull up, I'm going to drag that 1 up into the last box and make that a 13. 2. Let's see how close I can get to 13 without going over by using my multiples of 2. Remember, I'm doing the multiples of 2 because that's what I'm dividing by. 2, 4, 6, 8, 10, 12, 14. 14's too much, so I'm going to back it up 1. 2, 4, 6, 8, 10, 12. So 12 is as close as I can get to 13 without going over. 12 is the 6th multiple of 2. So I'm going to put a 6 up here. And then I'm going to say 6 times 2. 6 times 2 is 12. Line up my place values. Subtract out. 13 minus 12 is 1. Now, I'm in my last box, so this is my remainder. So the answer to 673 divided by 2 is 336, right here, with a remainder of 1. If there is a remainder, you have to write it. So I can't just put 336 and say that that's the answer to 673 divided by 2. It's not. It's 336, remainder 1. That R1 has to be with it. Now, if you made any mistakes, that's okay. Just go back and make corrections, which I hope you were doing while we were going over it. All right, let's look at another one. I'm going to write it this way now. 714 divided by 7. I'm going to give you 3 minutes to do that one. Go for it. All right, let's go over this one now. Now, this one's easy. How many times can 7 go into 7? Once, right? So we want to write 1 up here. 7 is the first multiple of 7. So 1 times 7 is 7. 7 minus 7 would be what then? 0. Nothing to drag up. I could if I wanted to, and remember, it would go right in front of that 1. So it's not really going to change the value, but you don't have to drag it up since it's 0. Now, how many times can 7 go into 1? Well, it can't. Watch. 7, 14, 21. When I look at the first multiple of 7, it's already too much. It's already over 1. So I have to put something there. How many times can 7 go into 1? Well, it can't. It can't at all. So I'm going to put a 0 there. It's not a ghost 0. It's a placeholder 0. Okay? So now 0 times 7 is 0. Remember, anything times 0 is 0. Subtract that out. 1 minus 0 is 1. Very good. Now, since I do have something left over in that box, I'm going to drag it up to the 4 and make it a 14. Very good. Now, how many times can 7 go into 14? Well, if I look at my multiples list, there's 14 right there. It's the second multiple. So I'm going to put 2 right here. 2 times 7 is 14. So I'm going to make sure that I line it up correctly. My 1s are underneath each other. My 10s are underneath each other. I'm going to subtract that out. And what do I get? I get a 0. I have nothing left in this last box here. So there are no remainders. So 714 divided by 7 equals 102. There are no remainders because in this last box, we don't have anything left over when we subtract it. So 714 divided by 7 is just 102. Now, let's look at another one. And you're going to do this one by yourself. Let's see. 563 divided by 8. And I'm going to give you 3 minutes. Go ahead and work on that one. All right, let's go over this one now. How many times can 8 go into 5? Well, when I look at my multiples of 8, I immediately see that even the first multiple of 8 is over 5. So I'm going to have to put something here. I'm going to put a 0 because even the first multiple of 8 is too much. So 0 times 8 is 0. Subtract that out. That leaves me with 5. I'm going to drag that 5 up to the 6, and it's going to turn it into 56. Now, if you know the multiples of 8, you can get really close to 56. But I know 8s are hard, so let's keep drawing our 8s list here. So 8, 16, 24, 32, 40, 48. The next one would be 56. Hey, right on, smack on the money there. 56 is the 1, 2, 3, 4, 5, 6, 7th multiple of 8. So I'm going to put 7 up there. 7 times 8 is 56. So I'm going to write 56 down here. And you know what 56 minus 56 is. 0. Very good. Nothing to drag up to that 3. And now I'm going to ask myself, how many times can 8 go into 3? Well, just like we had the problem with 5, the first multiple of 8 is already too big. 8 is over 3. So I'm going to put a 0 there to represent that 8 cannot go into 3 at all. 0 times 8 is 0. Subtract that out. I'm left with 3. Now remember, this is our last box, so this is the remainder. So the answer to 563 divided by 8 is 70, remainder 3. Remember, you have to include that remainder there in it. So 70 R3. Now, before I set you off for your independent work, Ms. Martinez will be passing it out soon. Let me show you what you're going to be doing. You have 5 problems here. 1, 2, 3, 4, 5. Now, not only is she going to pass out this paper right here, she's going to pass out a piece of scratch paper, notebook paper. You are to do the work on the notebook paper and write your answers here. No work will be done on this paper. Just your name and your number, and then your answers. When you are done, you are to staple it to the back of this paper, not the front. And then you're going to show it to Miss Martinez, and she will look at how you answered it. If it is wrong, she will circle the question number that is wrong and will send you back to your seat. Once you are done and all of them are correct, you are allowed to work on your menu or 99 Math Solo. Let me show you. There's a slide right here. Okay, so your must do is the worksheet, menu is your may do, and then 99 Math Solo or Extra Math. Miss Taylor should be pulling her group today. Now, you may go ahead and begin working on your independent work as soon as you get it. This is a quiet time, remember that.